Hello students, this is Miss Pooja Arun Mhatre, lecturer in Electronics and Telecommunication Department in Praveen Patil College of Diploma Engineering and Technology, Bhinder East. Today's topic is C&D, chapter number 4, Data Link Layer, part 4. The learning course outcomes are framing, fixed size and variable size framing, character oriented, that is byte oriented framing, and bit oriented framing. Framing. A physical layer accepts a raw bit streaming and delivered it to the destination. Physical bit Physical layer accept a raw bit streams and delivered to the destination. This bit stream is not guaranteed to be the error free. So the number of bits received may be a less than or equal to or more than numbers of bit transmitted, and they may have a different values. It is up to data link layer to detect error. The solution in framing data link layer breaks bit stream into the discrete frames and computer checksum for each frame. One of the purpose of the data link layer is to form the streams of bits received by the physical layer into discrete units called frame. A frame can also call a pack or a block. It is a unit to transmission. Frames are necessary for a packet switch network. A frame generally has a header followed by the transmitted data. A trailer often follow the data. Framing is a process of dividing the data for transmission into the group of bits and adding a header as well as checksum to form a frame is in an asynchronous communication. So framing is a process of inserting start bits and the stop bits before and after the data to be transmitted. So framing is the process of dividing data for transmission the data group of bits and adding a head as well as the checksum to form a frame. Fixed size and variable size framing. Frames can be fixed or variable size. In a fixed size framing, this is no need for the defining the boundaries of the frame. The size of itself can be used as a delimiter. An example of fixed size framing is the ATM van, which uses a frame of fixed size called cells. In variable size framing, we need to weigh or define that the end one frame or the beginning of the next. An example of variable size framing is a local area LAN. So historically, two approaches were used for this purpose, namely as a character oriented approach and the bit oriented approach. First one is the byte oriented, that is character oriented, and second one is the bit oriented framing. Character oriented framing. In this type of framing, data to be carried are 8-bit characters from coding systems such as ASC the header, that is ASCII the header, ASC is as the header, which normally carries the source and destination address of the other central information, and the trailers which carries error detection redundant bits are also multiples of 8 bits. To separate one frame in the framing from the next, an 8-bit, that is 1 byte flag that added the beginning at the end of the frame, the flag composed of the protocol dependent special character signals to start and end of the frame. So below diagram show the frame in a character oriented protocol. So data from the upper layer variable number of character. The frame is are in the bits are present in the blue color, and we have a header, and before the two ends are of the data are end with a flags. First after flag starting point is a header and then ending point is a trailer. Byte oriented framing was popular when only text was exchanged by the data link layers. So the flag could be selected be any character net used for the text communication. Now however we send other type of information like traffic, audio, video, any character used by the flag could also be passed off information. The starting and ending character with character stuffing. The ESC code is added in the another first row is showing the data from the upper layer, which is original data. Then header and for trailer is added, and the flag bits also added when sender transmit the data. At the receiver type, frame is received with the ASCII code, ESC code, escape code, then with header and flag. Then receiver unstuff the data, that is header, trailer and flag bits are removed from the original data and receiver get the original data. That is stuffing and unstuffing. Bit oriented framing. In this type of framing, the data section of a frame is a sequence of bits in the interpreted by the upper layer as a text, graphic, audio, video and so on. However, in addition to header, we still need a delimiter to separate one from frame from the other. The most protocol use as a special 8-bit pattern flag, that is 0 11111110, as the delimiter to define the beginning of and the end of the frame is shown below. Here the data from the upper layer variable show the data bits. So here also have a header and trailer and flag bits are added as a 0, 6 times of 1 and 0. The bits are separated by 0, 6 times of 1 and 0. The flag can create the same type of the problem we saw in the byte oriented protocol. That is, if the flag pattern appears in the data, we need to somehow inform the receiver that this is not end of the frame. So we do this by stuffing a single bit, single bit instead of one byte. To prevent the pattern from looking like a flag, the strategy is called a bit stuffing. And bit stuffing is a technique used to ensure that the specific bit pattern never occur in the data transmitted over a communication channel. So addition bits are added at the transmitting end and removed at the receiving end of the channel as the data is processed. Each frame begins and ends with a special bit pattern. Whenever the sender's data link layer encounters 5 consecutive ones, in the data automatically stuffed with 0 bits into the outgoing bit stream. So whenever the receiver sees the 5 consecutive ones in the data, is automatically destuff the 0 bit. Here the diagram showing the first original data is 0 110 10010. The original data is of the 16 bits. Then stub bits are added after consecutive ones, that is 1000110. 5 consecutive ones added a stub bit, that is 0. 5 consecutive one added as first is 0. Then 5 consecutive one added a stub bit at 0 and 10010. So the bit stuffing bits are get, so receiver know the after consecutive ones the bit is added as 0. So when the receiver received a bit, he unstuffed that 0 and received the original data. Starting and ending flags with bit stuffing. Here the first data from the upper layer is the original data. Then after 5 consecutive 0 bit is added. So frame sent to the receiver is adding the stub bits. Then frame received by the receiver is the extra bits added, that is stub data is received by the receiver. Then receiver unstuff the extra bits and get the original data. Thank you.